Hi, second grade scientists. Welcome to lesson 5 of this unit on matter, where we will be talking about the attributes of gas. Oh my goodness! What was that? I don't mean that type of gas. Oh my goodness! That's not the type of gas I mean at all. Today we'll be exploring air, okay? Not farts. Oh my goodness, that was so funny. If you're still laughing, I need you to turn that laugh off in 3, 2, 1, because it's time for us to start our science lesson. So I have a question for you. This is a really important question. Can air move an object? What do you think? Give me a thumbs up or thumbs down. Can air move an object? Well, let's explore this question. Can you think of a time in your life where you saw air move an object? Think. There are some pictures here that might help you to come up with some ideas. Okay, when you have an idea of when you've seen air move an object, I want you to turn and tell the person next to you. As always, if you're at home, you can tell your imaginary lab partner or somebody in your house. And if you're in school, you'll tell the person sitting next to you. I'm going to give you 15 seconds to share a time in your life where you saw air move an object. Ready, set, turn and talk. One, two, three, eyes on me. So yeah, let's go through some of these examples here. We've seen, maybe not in person, but you've probably seen on TV, hot air balloons lift up into the sky. So those hot air balloons are being moved by air. We've seen wind blow trees around, right? We've all seen that. Have you ever blown the seeds off of a dandelion and maybe made a wish? You were using air to blow those seeds like these. Have you ever blown on a pinwheel and watched it spin? Yeah, so you were using your air to move that object. Pretty cool. So today we'll be exploring this question. Will adding more air move an object further? Do you have any thoughts about that? Interesting question. Do you have any ideas about how we could explore this question? What do you think? I'm wondering if you've ever done this with a balloon. Are you ready? Watch. Oh my goodness! Did you see it fly behind me? Does that give you any new ideas on how we could explore this question? Will more air move an object further? Think. What experiment could we set up to test and find out the answer to this question? Again, I will give you 15 seconds to share your idea with somebody sitting next to you. Okay, so give yourself a minute to think of an idea of how we could explore this question. What type of experiment we could set up to explore whether or not more air would move an object further. Okay. Now you have 15 seconds to share your ideas with someone else. Ready, set, turn and talk. right, 1, 2, 3, eyes on me. So today we will conduct an experiment to explore this question. We're going to use something that real scientists use. They use something called a lab report. We're going to use that to guide our inquiry, to guide us in exploring this question. A lab report uses the scientific method to explore different ideas. So let me show you what that looks like. Okay, here is our lab report. And as usual, if you're at home, you can find this in your Google Classroom. If you're learning in school, then your teacher will give you this lab report. So make sure that you have it in front of you because you will need it for the rest of this lesson as we explore that question of whether or not more air will push an object further. So I'm wondering if you came up with a similar idea to me. What I thought we could do is we could use balloons to test and explore this question. So here's our lab report. I've already written my name and date. Make sure that you write yours. Okay. The first part of our lab report says problem and hypothesis. So the problem is always what we're trying to find out. It says here problem, what I'm trying to find out. Now I've filled out some parts of this lab report for you because it is our very first lab report, but there will be parts that you'll need to fill in. All right, so our problem is, will a balloon travel farther if it has more air in it? That's the question that we're trying to figure out. So the problem is already done for you. Now, we're going to need to come up with our own hypothesis. What do we think? So our hypothesis here, we already talked about problem. Now let's look at hypothesis. What do I think? Why do I think this? So let me see. Your hypothesis could either be, I think a balloon will travel farther if there's more air in it. Or it could be, I think a balloon will not travel any further with more air in it. And then you'll say what makes you think that. I think that because da-da-da-da-da-da. So you can pause the video here and please fill in your hypothesis. Your hypothesis is always going to start with I think. Okay, and then you'll go on to finish that sentence and say why you think what you think. Okay, welcome back. Did you finish writing your hypothesis? I'll share what I wrote for my hypothesis. I wrote, I think a balloon will travel further with more air in it. I think this because the harder I blow on a pinwheel, the faster it spins. So I think if I fill a balloon with more air, it will be able to move further. Okay, if you haven't finished writing your hypothesis, make sure that you do that now. And remember, your hypothesis has to have two parts to it. One part that says, I think, and you'll say what you think. You're going to basically answer your prediction for this question. Will a balloon travel farther if it has more air in it? So say what you think about that. And then you also have to have a part that says because. That gives the reason why you think what you think. Once you're all finished with your hypothesis, we'll go on to the next part, and you can unpause. You can pause this video if you're not done yet, and then unpause it to go on. If you're all finished, then we're ready to just keep going on to the next part. I can't wait to start this experiment. Okay, so the next part of our lab report and the next part of our scientific method has already been filled in for us. Okay, so we'll just go through it together. You're going to turn the page where it says materials and procedure. That's the part that we're looking at next. So the materials tell us what we need, and the procedure tells us how to do our experiment. We want to be really specific when we write this part. Today it's done for you, but in the future, when you're working on a lab report, if you're filling in your own materials and your own procedure, you want to be really, really specific. I wonder why. Why do you think it's important to be really specific? To really use a lot of details and tell exactly what you plan to use and exactly how you plan to do the experiment. When you have an idea, I want you to whisper into your hand. I think it's important to be really specific because you're right. It's so important to be really specific so that other scientists can do the same experiment that you did. Okay, so I'm going to walk you through now our materials and our procedure. Now, if you would like to do this experiment at home, this is what you'll need. If you're learning from home, you can do this experiment with me. If you're learning in school, you can repeat this experiment at home. Okay, so here's what you'll need. You'll need a fishing line or some other very thin string. You'll need a 2-inch piece of straw. So you'll need to take a straw and you'll need to cut it down to about 2 inches. You'll need 2 chairs that are spread 20 feet apart. Now they need to be really sturdy chairs so that they don't fall over. You'll need 3 balloons. You'll need packing tape or some other form of very strong tape, and you'll need a tape measure. All right, so now we've already talked about what materials we need. Next, we're going to go on to our procedure. What procedure will I follow? So you can follow along on your lab report as I go through the steps in this video. The first step says, first, feed the 20-foot fishing line through the 2-inch piece of straw and hang the string to 2 chairs 20 feet apart. The fishing line should be taut. That means really tight. So if you're following along and doing this experiment with me, you'll want to pause the video here to set this part up. And you can see here, I have fed the fishing line through the straw, and then I tied it to 1 chair, and then I tied it all the way across 20 feet. See, I have my tape measure here, measuring 20 feet. I tie it all the way across to another chair. Then our next step is to blow up the first balloon with 1 breath of air for the first trial. Our next step is to tape the balloon to the straw, being careful not to let the air out yet. The opening of the balloon will face the short side of the string. Okay, notice how I used packing tape? I first tried using just Scotch tape and I found it didn't hold the balloon very well. So I used packing tape instead because it's stronger. So you can use any tape that is strong enough to hold it up. Okay, and then finally, release the balloon, measure how far it travels, and record the results. So you could see here, this is me about to release the balloon. That's taped to that straw that's on the string, and then you can see me measuring here. And then you'll repeat these steps to do 2 other trials, and I'll show you what I mean by that. Okay, so now as we conduct our experiment, we need to write down our observations and our results. This is called data. We need to keep data on our experiment. Can you say the word data? Data. Yeah, so data is what we write down to record the results of our experiment. Now, this next part of our lab report, make sure that you're turned to the page that says Observation and Results. Please turn to that page if you haven't done so already. Observation and Results. Okay, so here we are going to write down our results. So the first one says the balloon with 1 breath of air traveled a distance of. When we do the experiment, we'll write that down. The balloon with 3 breaths of air traveled a distance of. And we'll write that down as well. And then the balloon with 5 breaths of air traveled a distance of. And we'll write those results as well. So are you ready to see what happens? Oh my goodness, I'm so excited. Notice here how I changed just one variable between each trial. So each time that we blow up the balloon, that's a different trial. And I changed one variable. That means I changed just one thing. In each trial, I'm still using a balloon. I use the same type of balloon. I even use the same color of balloon. But the one thing that I'm changing, the one variable that I'm changing, is how much air we put into the balloon. I'm doing the experiment the same exact way otherwise. Okay, that's really important in science. We only change really one variable at a time. So here we go. It's time to see what happens in our first trial. Trial number 1 is a balloon filled with 1 breath of air. Let's watch. All right, so for trial number 1, we're going to fill our balloon up with just 1 breath of air, and then we'll see how far that air is able to propel the balloon. Before we continue, how about if you make a prediction? How far do you think it will travel? How many feet do you think it might travel? Take a guess. Call out your guess in 3, 2, 1. All right, let's see. Let's see how close you came. Move it onto our straw here. Ready, set, go. Okay, let's see. As you can see, we have a tape measure here. So it actually dropped off. So this traveled, let's see, this is 6 feet, this is 7 feet. This traveled 7 feet and 5 inches. Okay, so now it's time for us to record our results. Let's go to our lab report, and we're going to record the distance that first balloon traveled. Do you remember how far it traveled? Yes, 7 feet, 5 inches. So write that down. 7 feet, 5 inches. Okay. Now, and I did the abbreviation for feet. Another way that you could write feet is like this. Okay. So now, next we'll do a trial with the balloon with 3 breaths of air to see how far that travels. Would you like to make a prediction? So the balloon with 1 breath of air traveled 7 feet, 5 inches. Make a prediction. Do you think it will travel further than that or not as far if we add 3 breaths of air instead of just 1? Okay, call out your prediction. How far do you think it will travel? Call it out in 3, 2, 1. Let's find out. Here we go. Trial number 2, a balloon filled with... Sorry, I had a little typo there, but I fixed it. So trial number 2 is actually a balloon filled with 3 breaths of air. Here we go. Let's see what happens. See if your predictions are right. Okay, now for our second trial, I'm going to blow this balloon up with 3 breaths. and we'll see how far it's able to propel. Take my balloon on. Ready, set, go. Wow, that time it went a little further. Let's see here. It traveled 11 feet, 4 inches. All right, how did you do with your prediction? Did you come close? Let's record now our results from that trial. The balloon with 3 breaths of air traveled, do you remember? That's right, 11 feet, 4 inches. 11 feet, 4 inches. And that's the abbreviation for inches, IN. Abbreviation for feet, abbreviation for inches. So far, does it seem like adding more air is making the balloon travel further? Yeah, so far it does seem that way, right? But let's confirm that. Let's do one more trial, and in this trial we'll have a balloon with 5 breaths of air and see how far that one travels. Okay, trial number 3, a balloon filled with 5 breaths of air. Okay, for our final balloon, our last trial, trial number 3, I'm going to blow this balloon up with 5 breaths of air. Let's see how far it travels. Go ahead and make a prediction. I want you to call out in just a moment how far you think this balloon will travel. Call it out in 3, 2, 1. Let's see how close your prediction came. Keep it on. Ready, set, go. Wow, that one went even further. Let's see. So, this balloon landed 16 feet and looks like about 1 inch. All right, so our last trial, the balloon filled with 5 breaths of air traveled 16 feet and 1 inch. Okay, make sure that you have all of that data written down. Those are our results. Now it's time for us to write about our observations. So here are the directions. Say, write about 2 things you observed during the experiment. So just think of 2 different things that you observed. What did you notice? Think. I'll start. One thing that I noticed is that the balloon with 3 breaths of air traveled further than the balloon with 1 breath of air. Okay, now you share something else that you noticed. Ready, set, turn and talk. One, two, three, eyes on me. Okay, now we're going to write down our observations, and we're going to start by saying, I noticed, or you could say, I observed. Okay, and then you're going to finish that sentence. Write 2 different observations that you made. You could even say, an observation I made was that. Okay, pause the video here, write down your 2 observations, and then unpause when you're finished. Did you finish writing your observations? I'll share with you what I wrote. I wrote my first observation. I noticed that the balloon with 3 breaths of air traveled further than the balloon with 1 breath of air. And then for my second observation, I wrote, I observed that the balloon with 5 breaths of air traveled the furthest of all 3 trials. If you haven't finished writing your observations, pause the video here and finish writing them. Make sure that you have 2. And then when you come back, we'll move on to the next part of our lab report. If you are all finished, then you're ready to move on. So let's see what's next. And flip to the back. Well, the back is the most important part of a lab report and the most important part of the scientific method. It's our conclusion. Say that word, conclusion. Conclusion. Very good. So here, we need to answer this question. Was my hypothesis correct? And then we need to say how we know that it was correct. This is how do I know? So in order to do that, well, we need to first look at what our hypothesis was. So my hypothesis was that I think a balloon will travel further with more air in it. That's what I thought. Look back right now and see what yours was. Was your hypothesis the same as mine or was yours different? A hypothesis, by the way, does not have to be right. Sometimes our hypotheses are wrong. That's part of being a scientist. We say what we think and then we prove or explore what we think. We either prove it or we disprove it. Either way, we're learning new information as scientists. Okay, so once you're finished reviewing your hypothesis, you're ready to answer this question. Was my hypothesis correct? So you'll either say, my hypothesis was correct, or you'll say, my hypothesis was not correct. And then you'll say how you knew. You can pause the video here, respond to this part of the conclusion, and then unpause it to continue on. Welcome back, everyone. Did you finish writing your hypothesis? And did you also write how you know that, did you finish writing about whether or not your hypothesis was right, was correct? And did you finish also writing about how you know whether or not it was correct? I'll share with you what I wrote. I said, my hypothesis was correct. I know this because the balloons with more air traveled further than the balloons with less air. Okay, if you finished writing this part, we'll go on to the next part. If you haven't finished yet, pause the video, finish this part, and then come back and unpause to move on to the next part. Okay, so for the next part of our conclusion, we want to think about what we learned. It says, what did I learn from this experiment? So think about that original question that we were exploring. Do you remember? That's right. We were exploring this question. Will adding more air move an object further? So did we learn that adding more air moves an object further? Or did we learn that it doesn't move an object further? What did we learn? Turn and tell the person next to you what you learned. Eyes on me in 3, 2, 1. So I bet you said something like this. I learned that adding more air can move an object further. Go ahead and write your response to this question now. You can pause the video and unpause it when you're finished writing. All right, I'll share with you what I wrote. I learned that adding more air can move an object further. Okay, now the next part says, were there any surprising results? Did anything about this experiment surprise you? Think. And then I want you to share with someone near you. Go ahead and turn and talk. You can start by saying, I was surprised that. Eyes on me in 3, 2, 1. Okay, let's see. I'm thinking for me, I was surprised that the first balloon with only 1 breath of air traveled as far as it did. I was surprised that it traveled. Let me see. I'm going to look back at my results. It traveled 7 feet, 5 inches. I didn't think it would travel that far. That kind of surprised me. So that's what I would write down that surprised me. I'm going to start by saying I was surprised that, and I'll finish my sentence. You go ahead and do the same. Pause this video here, answer that question, and then come back when you're done. Did you finish writing any surprises that you came across? I'll share what I wrote. I was surprised that the first balloon with only 1 breath of air traveled over 7 feet. I did not think it would travel that far. So if you're finished answering this question, we can go on to the next part. If you're not finished, make sure to pause the video, finish up what you're writing, and then unpause it once you're done. Okay, this next part of our conclusion is probably my absolute favorite. This part just says, what if? So remember how I said that scientists changed just 1 variable? So in this experiment, our 1 variable was that we changed the amount of air added. Now we want to think, well, what's one other thing that we could change to maybe change this experiment a little bit? So for instance, I'm wondering, one thing I'm wondering is what if we added 10 breaths of air? I wonder how far it would the balloon would travel then. Another thing that I'm wondering is, what if we used helium instead of air? I wonder what would happen if we tried the same experiment, but instead of using air, we used helium. Would you please think of a what if question, something that you're wondering, one thing that you could change in this experiment, one variable that you could change. What are you wondering about? Okay, turn and tell the person next to you. Go ahead. One, two, three, eyes on me. Did you come up with a what if? This can be a little bit tricky. It's really fun to think about because we can repeat the experiment, changing just 1 variable, and see how that experiment turns out. It's kind of fun. Scientists do this all the time. So now we're going to write this last part of our experiment. We're going to write our what if. Go ahead and write it. And you're going to pause the video again here. Write your response to what if, and then unpause it when you're finished. Did you finish writing your what if? I'll share mine with you. I actually wrote 2 what ifs because, like I said, this is my favorite part. So 1 what if, this would be one way that I could redo the experiment. What if I blew a balloon up with 10 breaths of air? That's 1. And then I could redo this experiment another time, and I could try this out. What if I blew up the balloons with helium instead of air? Interesting ideas, right? So I hope you enjoyed our science lesson today. Thank you so much for learning with me. This was so much fun. I hope you have a great day, and I'll see you next time. Bye-bye.